Welcome to our deep dive into the world of energy storage technologies. Renewable sources like solar and wind are fantastic, but they're unpredictable. That's where energy storage swoops in like a superhero. Today, we'll explore the top 5 innovative solutions making renewable energy more reliable and efficient. Get ready to have your minds blown wide open, because the future of energy is here, and it's looking bright. First up, let's talk batteries. Not the kind in your TV remote, but massive grid-scale systems that can power entire cities. We're talking about lithium-ion batteries, similar to what powers your phone, but on a colossal scale. Then there are solid-state batteries, the new kids on the block. They swap out the liquid or gel electrolyte found in lithium-ion for a solid one, making them potentially safer and more energy-dense. And let's not forget about flow batteries, which excel at storing large amounts of energy for longer durations, perfect for bridging those gaps when the sun goes down and the wind takes a break. One of the big challenges with batteries is their lifespan. Like that old phone that needs charging all the time, battery performance degrades over time. But scientists and engineers are constantly working on making batteries cheaper, longer lasting, and even more powerful. Next, let's take a trip to the mountains, where we'll find a technology as old as time itself: gravity. Pumped hydro storage has been around for over a century. Here's how it works. Imagine 2 reservoirs, one high up in the mountains and one down below. When electricity demand is low, we use surplus renewable energy to power pumps that move water uphill. Then, when demand peaks, we open the gates and whoosh! That water comes rushing down through turbines, generating electricity just like a traditional hydropower plant. Pumped hydro is fantastic because it's a mature technology with a long lifespan and the ability to store massive amounts of energy. But there's a catch. You need the right geography, meaning mountains and water. Ever wonder what happens to all the air we breathe out? In the world of energy storage, we can capture it and use it to power our lives. Compressed air energy storage, or CAS, is like stuffing a giant air mattress under the ground. When we have excess electricity, we use powerful compressors to squeeze air into underground caverns, old mines, or even special containers. Then, when demand surges, we release that compressed air, which rushes through turbines to generate electricity. CAS is particularly well suited for grid-scale energy storage because it can handle large amounts of power and release it quickly when needed. However, compressing air generates heat, and letting it out cools things down, meaning we lose some energy in the process. Researchers are constantly working on ways to improve the efficiency of CAS and find innovative ways to store and release that compressed air power. Ever notice how a hot water bottle stays warm long after you filled it? Well, that's the basic idea behind thermal energy storage, or TS. We can capture excess heat from various sources, like industrial processes, power plants, or even the sun. This heat is stored in materials that are really good at holding on to it, like molten salt or special concrete. Then, when we need to generate electricity, we use that stored heat to create steam, which drives turbines, just like in a conventional power plant. TS is super versatile and can be used for a wide range of applications, from heating and cooling buildings to providing process heat for industrial facilities. One of the coolest applications of TS is in concentrated solar power, or CSP plants. These power plants use mirrors to focus sunlight, creating incredibly high temperatures that can be stored as heat and used to generate electricity even when the sun isn't shining. Pretty neat, huh? Hold on tight, because we're about to explore the world of flywheels, where energy storage meets the grace and power of a spinning dancer. Imagine a large, heavy rotor, like a giant top, spinning at incredibly high speeds in a near-frictionless environment. That's a flywheel in action. These marvels of engineering store energy in the form of rotational kinetic energy, basically, the energy of motion. When we have excess electricity, we use it to spin the flywheel up to speed, like revving the engine of a superfast car. Then, when we need to release that energy, the spinning flywheel drives a generator, converting mechanical energy back into electricity. Flywheels are like the cheetahs of the energy storage world. They can respond to changes in electricity demand in a flash. From massive batteries to spinning wonders and the power of gravity itself, These energy storage technologies are paving the way for a more sustainable and reliable energy future. By overcoming their respective challenges, we can accelerate the adoption of renewable energy and reduce our dependency on fossil fuels. Thanks for watching, and stay tuned for more insights into the world of renewable energy.